स्टार्ट करें तो
Cool.
guys, today I'll talk about memory allocators in C, and it will be applicable for Linux and C because I don't know much about Windows API. So let's start. So first we will see what is the need for memory allocators. We'll start from history, how it began, how memory allocation happens at the basic level. So memory allocation is done using system calls like break and sbreak. So what happens that these call increase and decrease the heap pointer which allocate memory from the program heap. So here is an image for the heap of a program. As you can see, the previous program break, and after calling s break, the new program break increases. So the memory which we get, that is the allocated memory. This is a basic syntax to allocate a memory in C. So guys, this method had a few major disadvantages. So we'll talk about them. First of all is syscalls overhead. So we know that syscalls, whenever we call syscall, then the context of the program changes. It runs in kernel mode instead of running in user mode. So when switching from user mode to the kernel mode, it has its own overhead, and that overhead is not too small. It is appreciable. So if we use multiple times the same syscall, what will happen? It will make the program slower. Next disadvantage is fragmentation. So as we saw in sbreak, we can increase and decrease the pointer according to our wish. But what if the sbreak call is called multiple times in different functions? We don't know which part of the heap is pointed to which part of the function. So when we decrease the pointer, what will happen that some of the memory will be freed and some will be wasted in between. And another thing which is a disadvantage is copy and write. So copy and write is a mechanism which is implemented in Unix and Linux based systems. What happens that the memory is allocated, it is marked as read only, it is not written yet. But when we perform the first write operation on the memory, it copies the memory and makes it writable. This was done to save much of the memory usage and the time which was required in various calls like fork. Because what happens in fork, people generally call fork to execute another program. So it was just a wastage of time by calling fork and then copying the memory, which will already get destroyed when we call execute. So what does a good memory allocator should have? So these all are the things which a good memory allocator should have, and they are maximum compatibility, so that they obey the ANSI and POSIX conventions, so that we can run them in different systems without needing much setup. Second is minimizing space. A program at this level where we need to allocate memory, it should not much be of large size. If it will be of large size, it will just add up to the size of the program and it will be too much bulky. Next is maximum portability. So yeah, as I already told that it should depend on very less features such as system calls as possible. The next is minimizing time. So malloc free and realloc routines should be as fast as possible in the average case. And the last one is maximum error detection. For example, when we generally allocate memory in C, we are supposed to check if we are getting the memory or not, if it is sending null or anything else. So we should have some mechanisms to see and check for errors. There can be many errors like corruption due to overwriting memory. If we are using arrays, for example, there is a function yeah, it is get ch, I guess. I don't remember properly, but what it does is that once the buffer is over, it starts allocating, then it starts overriding the next memory. So it was a bug which had to be fixed in Linux. So similarly, error detection mechanism should be there. So a survey paper was done by some people, and the name is Paul Wilson and his colleagues, and they surveyed about which functions a memory allocator should have and which should be prioritized. So the conclusion was that they discussed that minimizing space by minimizing wastage, that was due to fragmentation, must be the primary goal for any allocator. So now we know that what should be the basic functions of an allocator and what should it have. Now we'll move to the implementations which have been done. The first implementation which we'll talk about is the DL malloc. It is a memory allocator written by Dog Lear. So what happens that in DL-malloc there are few algorithms that are being used. The two of them which are most important and they haven't changed through time are boundary tags. Boundary tags are basically structures which contain metadata and some tags at the beginning and the end of the structure, and there is space allocated in the middle. So this metadata can contain various information like is the chunk available for usage or is it already in use? What is the size of the structure? And B tag may contain links to the next structure like linked list. It is basically like linked list. So what was the advantage of this is that it gave us two advantages. First one is that if there is a used space between two free spaces and we are calling free on that, like you can see in the image on my left side, we are calling free on a block which is between two different blocks. So normally what would happen that there will be three separate blocks. But using boundary tags, we can just basically check if the next structure is free or not. And we can then coalesce them together to form a bigger chunk. This will prevent fragmentation. And not only that, you can see there is already link between and after the structures which point to the next and the previous elements. Similarly, the second algorithm which is used is binning. So what happens that binning is a mixture of array and linked list. So what happens that it is an array of sizes increasing through the power of 2. As you can see on the image on the left, there is an array with sizes 1, 2, 3, 4. The index are the size, and each index has associated with it a list which contains the number of structures which are already free. So if we can, what are the advantages? We don't have to search through all the blocks. Like in a normal linked list, we would have to search all the blocks, which block is free or not and what is its size. But here we can generally go to the index and we can search for it. And the disadvantage is that maintaining this structure itself will cost us memory. But nowadays we have systems where the memory is more than enough, so we can apply this. Now, now how we search about the free blocks, there is a strategy which is called as best fit strategy. What it is that we will search a block which exists in the bin. For example, we want a block of size 3, okay, 2 to the power 3, that is 8 bits. So we will go to the third index, we'll see if there is a block or not. If it is there, we'll use it. Otherwise we will go to the next one which has a bigger block and we will break it into two parts. This is the best fit strategy which is used. So guys, these two algorithms are used to allocate and free memory blocks in malloc. Malloc uses sbreak, the one which we discussed earlier, for the allocation of small blocks. But what it does that for larger blocks, it uses a new method, that is mmap or memory mapping. The benefit of memory mapping is that it maps the memories without holes. I cannot explain much about holes because I have not yet read about mmap, but I have heard about it, so I included it here. The only disadvantage it has is that it is much slower than sbreak. So dlmalloc only allocates large blocks with mmap. So as time passed, that dlmalloc was written around 1990s, and as the time passed, there were many more features like locality preservation, wilderness preservation, caching of the list in the blocks. And a big disadvantage of dlmalloc is that it can be used only for single threaded programs. It fails for multi-threaded programs. I have provided the source for the blog from which I have taken these and the source code for the malloc. You can read it. It is on GitHub. So another implementation is ptmalloc. This is the implementation which is being used by glibc, the C compiler which is used in Linux generally. I will not talk much about that. I will only say what it is. What it is that ptmalloc is just nothing but a wrapper which can be used for multi-threaded programs. It wraps the dlmalloc which we discussed earlier and uses pthreads library, that is the POSIX threads library, to provide such function. So the implementation details about ptmalloc can be found on the given link and the source code too. So I guess this is the end of our implementation section, and this was the end of how memory allocators are implemented. Thank you. I'm done.
Like the presentation actually. So do know that these topics are actually covered in the advanced operating system course, which is given in the fourth year. So I guess there are many people without the OS prerequisite. Uh, but yeah, then also the presentation was quite good actually.
Thank you.
So I had a question. Have you tried? Do you have any tools that I can use to sort of analyze the memory usage when you program?
Yeah, we have
Because
Valgrind and we have GTB. For memory allocations, we generally use Valgrind.
Valgrind. Okay,
Yeah.
cool. Yeah, thanks.
Okay, so I guess I'm next. Yeah.
Let's just, sorry, if you want, you can start a thread or someone taking notes. आज की meeting पे. We'll just list down topic और क्या हुआ, क्या बात हुआ, so that it's preserved.
Fireflies is taking.
Shehar, you can
Yeah.
just upload the link to your slides.
Yeah, sure. I'll upload it. I'll upload it in the chat.
Just put it in Slack or in the lightning talks that sheet is there. You put it there.
Sure.
Okay, so should I start next?
Yeah, go ahead.
Is my screen visible?
Yes.
Yes, yes.
Okay, so I'll present my lightning talk on some of the most interesting things I found about CPUs, that is branch prediction. But let's start with the basics first, how a CPU works. So, well, at the grassroots level, a CPU will just read some instructions from the memory, then load some data into the registers if needed, perform some computations on the data, and then finally store the data back into the memory. This is formally known as the machine cycle, which consists of fetching instructions, then decoding the instructions, and executing the instructions. So this usually happens. This machine cycle is just have it can take multiple cycles depending on the architecture and multiple other factors, but it usually happens very fast on the CPU in 10-20 cycles approximate. I mean, roughly for a typical instruction. First, next up, we have registers. Registers are can be compared to RAM to give an analogy sort of thing. Like RAMs are much faster than a hard disk, but it is still slower. Like if you see in this diagram, it will take 62 nanoseconds to access some data from the CPU to the from the RAM. This is equivalent to some 100 or 200 clock cycles. But registers, as you can see here, are only zero point 0.3 nanoseconds. They can be accessed in just one clock cycle itself. So the disadvantage is that registers usually store on much less data. Just there are just 1632 registers in the modern CPU, but these are very fast. There are different types of registers. Some are instruction registers. I mean, there's an instruction registers that stores the currently being executed instruction. There are data registers and address registers that hold data or memory addresses. You can see here are some of the x86 CPU registers. These basically are just, I mean, these are the ones that are accessible to the developer. They can use it to store variables or counters or memory addresses. Pretty much anything can be stored here. They're 64-bit long, 32-bit long, 64 bits, I mean 16 bits and 8 bits. Next up, we have some instructions. Well, the instructions are like the basic instructions. These are some of the basic instructions that can be directly fed into the CPU. If you know the OP codes for these instructions, you can directly load them into a CPU without the need of compilation or anything else. There are like various kinds of, I've just written the most basic ones. There's a mov instruction that moves the contents of memory register A into B, or from memory into registers, etc. Then we have the push and the pop registers, I mean instructions that can store data or retrieve data from the stack. We have learned about stack in the semester 1 or 2 programming data structures labs, so I won't go into the depth of it. But it basically stores anything that might be used during the program execution, the variables that are used during the program execution. And then there are also mathematical ones such as add a b, which will add a and b and then store the results. There's also a subtraction one, the multiplication one, division, xor, and various other operators. So once we are done with the basics, let's get on to this one, branch prediction. There is a very famous Stack Overflow question. In fact, I think it is the most voted question. I mean, the most voted question on Stack Overflow on why processing a sorted array is faster. Let's see the code here. One sec. Yeah, can you see the code on my screen?
Yeah, we can
Yeah.
see.
Yeah. So this is just a simple C++ C++ program which will create an array of size 32 kbs and then store random numbers in it from 0 to 255. Then it measures the time it takes for it checks if the data is, I mean, the value in the array is greater than 128, and if it is, it will be added to this variable called sum and then finally printed. It will take the time to, I mean, it will measure the time it takes to execute this part of the this statements. So let's see what happens without sort. I've already commented out sort, and let's just compile it and then run it. So in this case, you can see 2.88 seconds. And if I just go there and uncomment this part, just sort the array in the I mean ascending order, let's see what happens. See, it's almost 3 times faster than not sorting the array. The original question even mentioned up to 6 times in speed, but that was in 2012, and C stuff has gotten more advanced. Also, another thing to note that is that I'm disabling all compiler optimizations. If I don't, it'll just do some compiler magic and then make the speeds equivalent. So let's get into why this happens. But first, let's understand what pipelines in CPUs are. So I mentioned earlier how the fetch decode execute cycle happens one after the other. That is, one instruction is first fetched, then the data is retrieved related to it, and then it is finally executed. But this is not exactly correct. In modern CPUs, we often fetch instructions together, I mean, one after the other. Like, as you can see here, the yellow instruction is being fetched in cycle number 1. In cycle number 2, it goes to the decode stage where this yellow instruction is being fetched and the green instruction is being fetched. Sorry, the yellow one is being decoded and the green one is being fetched, and so on, and till finally at the clock cycle 4, the yellow instruction is being written back, the green one is being executed, the blue one is being decoded, and the red one is being fetched. So basically, you can see that every let's assume that each clock cycle is 2.5 nanoseconds big. So for the yellow instruction to go from 1, 2, 3, and 4, it takes 4 into 2.5. That's 10 nanoseconds of delay in processing the entire instruction. However, the next instruction is processed after 2.5 nanoseconds of the first instruction itself in the very next clock cycle. So this is, let's just go through terminologies. The latency is the time it takes for one instruction to complete. That is, one instruction is fully complete in 10 nanoseconds. And there is another term called throughput. Throughput is basically how many instructions are processed in how many nanoseconds. So in this case, the throughput is 2.5, I mean, one instruction per 2.5 nanoseconds, because you can see the green one is being processed just 2.5 nanoseconds after the yellow one. But there's an issue here. The issue is with conditional statements, that is, if-else statements and the likes. So we have a problem with if-else statements. We don't know whether the if condition will be true or false, and then whether it will jump to some other instruction or it will continue the instruction inside the if loop, I mean the if block. So there's a very naive solution. We can stop. Let's assume that the yellow statement is if condition, like some variable is equal to true or not. And if it is true, then we will be executing the green, blue, and red one. So a very naive way of doing it would be to just hold the execution of the green, blue, and red till the yellow instruction has finished process. But this will just be wasting throughput since the other pipelines will be just sitting idle. So we have invented branch prediction. Branch prediction, basically what it does is that we will be predicting what branch will take place. Like it might be the true statement or the if false statement. We will just be predicting one value. Let's assume it predicted. Let's assume that we have predicted true. So we will already compute this instruction along with the yellow one. And when the yellow one has finished processing, we have the green, blue, and red ones ready. This comes at a cost though. If we mispredict any of the values, we will have to throw away the instructions that were already processed, like the green, red, and blue ones, and then start again from the else condition. This will result in a code slowdown because it takes some CPU cycles to throw away the existing data and then some more CPU cycles to to process a new data. Modern CPU has a lot of pipelines, so throwing away the process instructions and then recalculating the new ones will take 10 to 20 nanoseconds. For a 3 GHz CPU, that's around 6 nanoseconds of delay. And this is what was going on in the C++ program. So, one second. When we are not sorting the array, this if condition, it can either be true or false. Like we have no certainty because the data is in the 0 to 255 range arranged randomly. So it might either be true or false with a 50-50 probability each cycle. But if we sort the array, the first half of the array will always be less than 128 and the second half of the array will always be greater than 128. And the CPU exploits this. The CPU knows that it will be greater than 128. So why is this font? Okay, never mind. So yeah, it will know that the size, the data is greater than 128 and it will always start processing this sum data alongside the if instruction. So it's very fast. With randomly sorted data, there is no way to predict what is going to occur next. There are some common types of branch prediction. In the very beginning, we used to have static branch prediction. In this case, like in the very first IBM CPUs, we always assumed that the conditional jumps either executed true or false. This was directly hard coded into the memory. So if it was already considered false, then we won't even calculate the ones that are being in the if block till the if condition has finished being processed. Then after that came out dynamic branch prediction. Dynamic branch prediction basically means that the result will depend on what happened in the last if condition. Like say if the last if condition was true, then it is probable that the next if condition will be true too. This is basically what was occurring in the code that I just executed. So, and there's also one thing like if it depends on more than last two ones, they usually use something like called Markov chains. Markov chains are often used to decide what the next value will be. And then finally, now the most modern and state-of-the-art CPUs use neural networks to process whether the branches will execute to true or false before it has actually finished execution. Now, I'm not very sure how this works myself. This was very complicated and I couldn't understand how it works. But and there are also various other types. Some of the types were not as widespread implemented, so I've not included those. You can see the rest of the types on the Wikipedia page for branch prediction. And that's my talk. Thank you.
Thanks, Soham. That was quite interesting. By the way, is that your UPI?
He presented his UPI.
Shehar also gave his PayPal link and other things.
Yes.
Yeah.
Nice. Nice. Actually, we had this same stuff in our computers architecture and operating system course,
You-
but
Mm.
like I think you explained it quite.
That was the full course.
Yeah, you actually explained it better than my prof. To be honest,
Yes, thank
that
you.
was quite nice.
+1.
Hello, sure.
So,
Hello.
yeah.
Yeah, yeah.
Good. A good presentation. I really liked the presentation. I remember actually I saw this exact Stack Overflow question once. I think a few years back. I found this exact error, like, oh, what is happening? Why was this slow? I remember seeing that answer. There was very big words. It was written branch predictor, something like that, right?
Yeah, yeah, yeah.
Yeah, interesting work that you
Yeah.
took that answer and you made it
Hmm.
into a presentation.
I
Good.
basically read that Stack Overflow question, and then I had this idea to make a lightning talk on this one.
Mm-hmm.
Uh,
Yeah, it's
one,
very good content.
one small correction I want to make is that when you speak THROUGHPUT, it's not throughput, it's throughput.
Oh yeah, sorry, I keep on making that mistake.
Also, by the way, Shoham, do you have proton color blindness?
Which one?
Like, do you have color blindness?
Yes. I
Exactly. That's the
thought
reason. I
Yeah, I also understood that.
I should have probably asked what the color was
No.
before
I mean,
talking
it's
about
fine.
it.
I mean, so one of my colleagues actually has a color blindness. So we deal with heat maps. We usually have blue and red color of heat maps. He uses some other color scheme, which we had to adapt to because he couldn't see the difference between blue and red properly. So
Hmm.
when you were saying that it was like blue, you refer to green color as yellow and purple as green. I was like, oh, what is happening?
Yeah. Basically, my color blindness is not that severe. Like I can see the difference between the two colors, but I can't really identify which one is which. That thing.
Oh, interesting. So like, does that impact any of anything else? Like, do you use some kind of other kind of color scheme in your editors or other things?
No, no. Like I can differentiate between the two colors, so I don't really use. I'm just used to the existing ones, existing color schemes.
Right. All right. Interesting.
Hmm.
Okay.
Have you like
Also,
found this? There's a really interesting blog on like branch prediction and the Intel AMD vulnerabilities in CPUs.
Yeah, yeah, yeah. I read about the vulnerabilities, but I'm
Shit, I
not sure
forgot what they
which
were
blog
called
post.
suddenly.
I think it was that one. The
Skyle is
Intel.
what it was. Shit.
Yeah, there was a very big one due to race condition, I think.
There was a
That
really
one.
good blog on why like branch prediction after 2018 in CPUs slowed down because of
Yeah, yeah, yeah.
security.
Yeah, that
Uh,
vulnerability that came out in the Intel CPU. I think it was due to some race conditions. Like I have to check which one it was.
so have you like tinkered around, like tried to build your CPU of your own?
I'm aiming to, like, I have made some very basic ones using like logic gates, but I've not made a full fledged good CPU that uses branch prediction or anything else.
Okay,
Like I want to do it.
that would be a bit a bit difficult, but you can start with a single cycle CPU. Like you don't know Verilog?
Mhm. How should I make it? Like on Python, JavaScript, I
No,
mean
no,
MATLAB or
no,
something?
no.
Then?
You do hardware designing on Verilog.
Oh, yeah, yeah, yeah. I was learning basics of Verilog. Okay, so
And
just
yeah, and there is
while
a Shehar also mentioned. It's getting late, so but I just
yeah,
wanted
sure.
to pitch in this. So as Shehar mentioning is risk free. So you'll see that there is some issues using CISC type of processors. There is a difference in pipelining CISC
Yeah,
processors
yeah,
and
yeah.
RISC processors. There is a difference in. So
Hmm.
let's see. So I guess I'm next. So I guess I should start. Is the screen visible? Hello.
Yep.
Yes.
Okay. So, yeah, so my topic is SQL injection. So like I'll start with some basic, pretty basic of SQL.
Like SQL stands for Structured Query Language.
Rajiv, can you be a little louder?
Oh, uh, just a second. Hello, hello.
Yeah, okay.
Is it
Yeah.
okay? Yeah. So I'll start with some basics first. So SQL language. So SQL generally stands for Structured Query Language, which is designed for a relational database management system, like a database management system which uses rows and columns for storing data. So like whatever we like pretty basic command or a transaction in SQL is known as a query. So like this would be the word query would be used somewhat. So like I would like to tell about some basic pretty SQL commands. Like the select command is used to retrieve certain columns from certain tables. Like for example, like if I need to take name and phone number from the directory table, so like this would be the command. The where keyword is used to impose some condition in a query, and so like if we want to extract some particular rows which have a particular data which we need, so that's what the where command is used. Next is the union command. Like the union command is used to merge data of two different columns, but a single condition appears, like the number of columns which we need to add in this, like to make a table should be same. Like like if I assume there's a database like a table time with hour, minute, and second. So the command like hour and minute can be merged together because they have the same number of columns, one. But if I do a union of a table like of one column and two column, that would throw an error. So like this is a pretty bad syntax. So yeah. So a drop command is used to delete and remove a table from a database. And truncate only deletes the data and leaves the table empty. So like a certain symbol like that would be used, like the comma is known as a hack symbol, like it's used generally for like SQL injection. A double dash is used for commenting out the rest of the statement. A semicolon marks the end of a statement, and star and hash are used as wildcards. So like if I want to extract all the rows from the directory table, like doing select star from directory would give me all the columns present in the directory table. So now moving on to SQL injection. Like SQL injection is in pretty basic terms, addition of data or manipulation of data in or changing an SQL query such that what we want to achieve is basically done. So like instead of typing a password like original password, we type star or one is equals to one dash dash. This would be a pretty basic hack. Like I'll talk more on this. So injection, there are a lot of injection mechanisms. Like basically there are two types of injection mechanism, first order and second order. First order basically deals with changing SQL queries such that no changes in the databases are made. It's only what we see and what data can be retrieved using the hack. But in second order injection, the changes are made in the database. So like it's a pretty severe kind of injection. Like it's an example of a injection of first kind, like through user variables. Assuming that I have a query which states like there's a users table and I'm extracting all the rows and columns from where I need where the user password and phone number of a particular user is being checked. So like if I have a user in the table with a username admin, password as a password, and phone number 100. So if the user enters admin username as admin, password as password, and number, then only this command should be executed. Otherwise, not. But instead, like a hacker or someone comes in and types the password as something like this: star is or one equals one dash dash, instead of the of a random string password. So what will happen is like uh, the dash dash would comment out the rest of the part which we don't need. And what happens here is like uh, and a combination of and or, and 1 is equals to 1 would always be true, and this whole combination would always be true, indeed whatever password we type. So it doesn't really matter what the password we have entered or the username what we entered. So like we can extract any amount of data and anything from a table, like using just this hack. So like this all depends on how the query has been made and stuff. So next, like second order injection attack. So where the data in the database can be altered. So like I would like to explain this using a simple example of a register and reset password system in which is present in uh, almost every site. So like assuming we have a account on a certain website and it uses SQL database with, and I have a username as injection. We don't know the password of the username injection, but I need to change the password. So what can be done? Like I'll create an account first with a username injection star, like double quotes dash dash, and I type a random password. Like I'll just create a user which I don't need actually. So now in the database, I would have two users, one with a username injection and another with a username injection double quotes dash dash. Now what can be done is with this user logged in, we would type the old password with just a random string and new password what we want the password to be set for the username injection. So, and when we reset the password of the username injection would be changed. So, how would this be done? Like if the query has been made not made very nicely. So, assuming that the query would be made like update something which we don't need, like like update from like the table name would be here, update this, set password as a new password, where username would be this and the password would be the old password. So if an original user needs to change the password, he would need to type the username and the correct password. But since a username has been typed as injection star double dash, the query would replace from something like this to this, where the password field has just been commented out. So we actually don't need the password to change the old password to change the password of the injection username. So basically, this is how the password of account can be changed very easily. Like this is a very basic kind of SQL injection on the second order. So like why can what is the help of why would an SQL injection would be done? Like it helps to extract data, like, and modify data of any place. Like we often hear a lot of data being extracted and being manipulated. Like it's just done so by passing authentication. Like what this example, we actually bypassed an authentication. So we actually didn't need the password, but we could change the password of another user. And privilege escalation, like an example of privilege escalation would be like we would change the what data what privileges we have using an SQL injection. Like it would be pretty basic though. And like this is a very simple meme, mm, like the it's pretty basic, like, and that's all. Thank you.
It was
Thanks.
quite good
So
actually.
interesting. Nice.
So, have you come across something called an SQL map tool?
SQL?
SQL map.
No, not actually.
So, it's like a automated tool that helps you find out SQL injection vulnerabilities in a website.
Okay.
And try it on a few websites of your choice, but don't try to do any SQL injection. Otherwise, you'll go to jail. So, be careful.
Yeah, sure, sure. Thank you.
And what do you think can be a good mitigation to this?
For what? Like
For
uh,
SQL injection?
using like what a query using user input for the user input, like if I not hard code as like concatenation of strings, I put as a user variable, like using a question mark and like doing that, for the example I showed, that would be passed, like
Okay, there is a specific term for this. It's called sanitization. So you can read upon it actually how sanitization works.
I read about that term but do not use it actually. I would read more on this.
And yeah, another tool is you can use an ORM, which like you will be standing on the shoulder of the giant, so generally you won't have a vulnerability. You think it doesn't have a vulnerability. And yeah, and one small thing that is just nitpicking. When you say that a transaction is a query, it's not entirely true. Uh, a transaction is a set of queries that are executed at once. So this is the difference actually.
I
That's it.
guess I missed that.
Like it will be either executed totally or it will not be executed. Like all the changes it did would be rolled back.
So like
That's
if I
what a
have a number
transaction
of
is.
queries, if all the queries are executed, that would be called as a transaction.
Yeah. So for example, let's say there is a bank doing a transaction, like he is to do some net banking, subtract some money from your account and add to somebody else's account.
Mhm.
So that would not involve just one query. It would involve
Yeah.
multiple queries doing checks whether you have the required balance or not. So if you do have the required balance, then he will do then the bank server will do the transaction. Otherwise, it will stop mid query and roll back everything it did.
Yeah.
So that's what transactions are for. Yeah, that it was a nice talk overall. So who is going to go next?
Does anyone have any
Put the
questions? CTMs,
so
executives. This feels like a very one-way uh,
just
interaction. Any questions you want to ask? Cool. I guess no. Let's go next.
Sure, yeah. Just a sec, I'll be sharing my screen. Yeah, is my screen visible?
Yep.
Right, so hi, I'm Ishan. I'm going to talk to you about design patterns and principles. So motivation, why is this something I should care about? The basic reason is that all software isn't equal. When we say this, we mean for a particular problem, you can have multiple different solutions, or you can write code to solve that problem in multiple different ways. So then how do you compare two different pieces of software that achieve the same goal? So we define certain desirable qualities that software has, and using this, we can compare those pieces. So firstly, correctness, obviously, you want both pieces to work. But again, you can define things like understandability, efficiency, and maintainability. All of these are desirable qualities that software should have. Further, you can group these, you can subdivide these into dependability, security, portability, things of this nature, and the list just goes on. So now when you're writing software and you have so many objectives that you want to optimize for, so many things that you need to keep in mind, it can be really difficult to really plan out how you want to make a large project. Um, so then at that point, you have basically two options. You can either spend 6 months planning, you just spend that time on the drawing board, trying out every possible solution, trying to find merits and demerits, or you can dive right into the first maybe one or two solutions that you can think of. Um, Obviously, both of these are not really optimal ways to go about this. Something in between is what we want, and that's where design patterns and principles really come in. So the main idea here is that we use the Pareto principle, or the 80-20 rule, where we're able to get reasonably good design, things that you'd probably get after 6 months of planning without having to spend those 6 months. Again, you're not getting as good, but you're getting reasonably good design at a fraction of this investment. That's the motivation. So what are design principles? Design principles are high-level abstract guidelines that really tell you how you should write your code and what it means for code to be good, essentially. These are not implementation or language specific, and I'll give you examples. So dry is something most of you may have heard about. Don't repeat yourself. It basically means don't copy and paste code. You should probably factor it into a function or a class that's reusable. Again, there's KISS, keep it simple, stupid. This is also quite a popular one. Another one I want to talk about right now is the single responsibility principle, and I'll get to it in just a second. Before that, I want to talk to you about the SOLID framework, which is essentially a framework comprising 5 principles. You have S, which is single responsibility, O for open close, and so on. You have 5 of these principles, and together they comprise this framework. It's quite a popular framework, and it gives you these principles that you follow when writing software for software to be better, essentially. But where's the magic happening here? All right, you're giving me these guidelines. Why is this something, again, useful? So the way I like to think about it is a proxy. If I want my code to be something like modular, then targeting modularity is something that's difficult. I don't exactly know what modular code looks like, right? I may have a good definition for modularity, something like this, that a system's components can be separated and recombined. This is a great definition. I understand this, but I don't really know how to write code for this. So I use SRP, the single responsibility principle, as a proxy for this. And I say that, okay, a class should have only one reason to change. And this essentially means I want to decouple its dependencies. If this class depends on some other class, I maybe want to insert an adapter there, things of that sort, where I'm not frequently changing this class, or this class is not having multiple responsibilities. So this essentially makes my code more modular. And this is a sort of a real world target that I can achieve rather than something as abstract as modularity. There's a slight caveat here that SRP may not be sufficient or necessary for modularity, but in general, if you use a principle like SOLID, you can generally get pretty close to things like modularity and maintainability, things that are desirable in software. But again, we're not doing mathematical proofs. Nothing is a real guarantee, so to speak. This brings me to design patterns. Contrast this with principles by saying design patterns are sort of low-level solutions. While principles are merely guidelines, design patterns are actual solutions to problems that keep coming up in software, or to design problems, essentially. If you have a certain real-world problem, how should you model this problem to go ahead and solve this effectively? So the real advantage of design pattern is that you don't have to reinvent the wheel, so to speak. People have already done that for you. It's been tried and tested. These do provide implementation details, which is why they're so useful. And they can be language or paradigm specific. When I talk about paradigm specific, I mostly mean object oriented. That's most of the principles there. And language specific might be, depending on how a language handles concurrency, you can have different patterns that are used. So they are grouped into these 3 or 4 classes. These 3 are from a very famous book, I think around the 1990s, on design patterns. It's called The Gang of 4 because it had 4 authors. And they classify all patterns into these 3 categories. But modern systems, we recognize the 4th category of concurrency. I won't be talking about this much. So for examples, singleton is an example of a creational pattern, and I'll be talking about this. You have adapter, which is structural. You have iterator, which is something you guys might be familiar about, used very often in C++. And this is a behavioral pattern. And finally, you have read-write locks. Again, this is a popular one. This is a concurrency design pattern. So as an example, I'll talk to you about singleton. And the idea behind a singleton is that you have only one instance of a class at a time. Where is this useful? A very common use case for this is a database or other such resource handler. So when I'm connected to a database, I probably want a single handler, unless, in most cases, I want a single connection rather than multiple, depending on how many resources I have. And this single connection needs to be shared with multiple parts of my code. So a really clean way of doing this is by creating this one database connection class and converting that into a singleton, such that this one single instance can exist at a time. Again, this provides implementation details. I won't go much into it, but how you do this is by making the constructor private or protected, and then by offering this get instance method, which is responsible for initialization of the instance and then returning that whenever it's needed. Yeah, and it stores this instance in this member function, which is static. You can also make this singleton thread safe by using locks. The common lock can be used, but that's slightly inefficient. So we use double check lock, which is in fact another concurrency design pattern. So this is an example for design patterns. Now I want to talk to you slightly about how this is relevant in particular to open source. And here's where communication comes in, which is a secondary benefit of using design patterns or principles. Just compare these two things. Imagine telling someone this and just compare that to telling them this. When you use things like design patterns and principles, you're able to communicate very effectively. Using these single words, you not only talk about what you have done or how your code is structured, you also talk about implementation details. And this just makes it really concrete and easy to communicate with each other. And you don't have to go ahead and explain every single solution that you've made. This is in particular relevant to open source because open source necessarily means you have distributed teams and you have infrequent, if any, in-person or telephonic discussions. This means it's really difficult to have proper conversations where you're talking about and can discuss and explain your solutions. So at that point, if you have these principles and patterns to fall back on that make communication really easy, it's really useful and helpful there. Secondly, when we talk about open source, we recognize that open does not necessarily mean accessible. We want accessibility to be a goal, but open does not sort of imply that on its own. To make things accessible, we want beginners to feel comfortable. And one way to do this is by using recognizable patterns that they might be familiar with. Again, you can make arguments that, all right, maybe having a term like singleton will scare someone away, but I think it's the other way around. When you see a term, a concrete term like this, you can search for it, you can Google it, and instantly you can find all the advantages of using singleton, what a singleton is, how it's implemented, and so on. And this is a really helpful way, I think, for beginners to be onboarded into open source projects. Again, this is not a panacea. There are caveats. There's the obvious caveat that you're using sort of a ready-made solution and you're fitting that into your problem. This may not be the best thing to do, but again, the 80-20 principle applies here, and you're saving out on those 6 months of planning. For this reason, I think it's just a really important tool to have in your toolkit whenever you're going ahead and trying to solve certain problems. That'll do for me. Thank you. I'll take any questions right now.
Yes.
This was a really cool. Thanks.
So for a long time, I have been scaring this topic, but I guess I should take a look actually. This reminds me of have you gone through the lecture series in YouTube that is present by Richard Martin on
No, I
plain
don't
code?
think I've answered
Like
that yet.
that communication part actually was there in the talk, and I liked it actually. So remember.
Okay, no, I haven't seen that yet. I'll make sure to check it out.
I think this is like an open question to everybody, but how do you like enforce certain design patterns when you want to write a tool? Like, how do you like get into thinking that I want to implement, say, an API? How would that comply uh, with a specific design pattern that I have in mind? But isn't like CI after code? Uh, okay, I guess this was a joke probably. But yeah, just like how do you start with that process of designing good software?
I think you
So
you rely on your reviewers to deny your PRs if they don't follow certain design pattern. I remember when I was contributing to, there was this repository from MetaKGP called Leprechaun. So that was written in Go, and there were certain ways I was writing some code, but Kshitij and Siddharth, so they both were, Siddharth was the one who wrote the repository from scratch. He told me that to write certain code in certain ways. So in Go you can do things like in a non-concurrent way and in a concurrent way. So he told me to separate those two parts so that even when I need to write or call a function in a concurrent way, I can do that. And if I want to do it in a non-concurrent way, I can. If I want to do it in a concurrent way, I can call that function asynchronously. So some parts you write and you get it reviewed from other people. Probably that helps with getting into mindset of how to write or how to adapt to a proper design pattern. There is one more in Python called EAFP, which is basically easier to ask for forgiveness than permission. So you see, in dictionary, whenever you have to check for a key, you can do that by like if key in dictionary, then do this, else do that. So that's not usually promoted in Python. That's you rather do a try catch block. You try and do whatever you want to do with that dictionary. If something fails, then handle it. So there is one more such thing. So yeah, I mean, if you keep writing code and look at open source, design principles, you'll get come across these things.
Okay, makes sense, I guess. Since you mentioned Go, what is like the opinion on languages that enforce certain designs? Like Go does, because you can't use assertions. Most Go programs expect you to write code a certain way versus, say, C++, where there aren't standards as such, and there are multiple style guides. There are like companies that have their own set of rules. How does like this translate into software? Does a language enforcing design somehow ensure better software?
You should look at Haskell. You should look at Haskell. There is no other way to do one thing. There's only one single way. I mean, it's yeah. I mean, so yeah. Continuing from the discussion in that Leprechaun repository. So I used to use certain kind of spacing and indentation in my code. Uh, but Kshitij said that there is a proper tool called GoFMT which we can use to format the code, and that's how other Go reviewers expect to see the code when they review it. And it kind of confused me at that time because I didn't realize, because in Python, like, you can have your own indentation spacing, like 2 spaces or 4 spaces, or you can convert into tabs. But yeah, I mean, I think implementing or forcing one particular standard makes it easier for you to collaborate with others. I think it's another layer of cohesiveness to the project, I guess.
So Divya, like, don't you think the linting and formatting is a subset of the whole design pattern of a
Right, right.
software? Like, sometimes it gets like bit harder than that CI check was his joke for sure. It's like at some level you need human eyes, to judge how you're doing things.
Right. Yeah, I agree. I mean, like, yeah, I mean, especially that indentation thing. Like, if suddenly I see a code which is indented in a certain in a completely different way. Like, some people use 2 spaces to indent their code. I mean, that can be like jarring at first to when I started to review it. But yeah, I mean, yeah, it's also like definitely a subset of design principles. Yeah.
Cool.
Who's next? Yeah, can we do the next person?
Yeah, it's me.
Yeah.
Are you the Linus Torvalds guy?
I was.
Say, looking forward.
Wait. Utsav अगला नहीं है.
No, it's me.
Oh, there's a change. He's first.
Okay, good.
So is my screen visible?
Yep.
Yeah. So hi, I'm LIKHITH. So welcome to the Lights 2021. So like most of the people here don't need an introduction for this light. Like it's the Linux kernel, right? Like it's the best operating system out there. So actually Linux has been changing every day. Like every single day, but it's the world's best software, like in kernel industry. So why is that? Like it's not even constant. So as far as I know, according to a TED talk by the moderator of Linux kernel, he told that has been changing 10,000 lines per day. So like this is not my topic today. So what I'm going to speak about is some knowledge which is eternal, like which has been existing from several thousands of years. So, like, my topic for today's session is compiling Bhagavad Gita, short BG. So, how many of you have here previously read Bhagavad Gita? Okay, no one. So, let's start the session. So, why Bhagavad Gita for likes? So, we don't ask why, we ask why not. So, for Bhagavad Gita, like, it has been there for ages, like even before the mankind. So there has been so many editions of Bhagavad Gita, like written by some different persons, different authors. So what is the most best version? Like the most best version is from the speaker itself. So let's hear what critics say about Bhagavad Gita. So the first thing is, for a while in his youth, every week, X used it to walk 7 miles across town to the Hare Krishna temple for the Sunday feast. He was a lifelong vegetarian. So can anyone tell me who the X is here?
Well, Steve Jobs now.
Yeah, it's Steve Jobs. So the second quote is, when I read the Bhagavad Gita and reflect about how God created this universe, everything else seems so superfluous. Who said this? Any guess? It's Albert Einstein. Third one is
those are fake quote. Einstein का fake quote है. Einstein never read Bhagavad Gita. There are some many fake quotes of Einstein. Among them, this is one, and one more one is we should credit Indian system. But never mind. Continue. Sorry, sir. Continue.
Yeah. I don't know. Thanks for telling. So third one is the secret of Karma Yoga, which is to perform actions without any fruitive desires, is taught by Lord Krishna in the Bhagavad Gita. Like it is said by Swami Vivekananda. And this fourth big one is told by Mahatma Gandhi. So I have been telling about like there are different versions. So what is the main version? So the man here is A.C. Bhaktivedanta Swami Prabhupada. Like he wrote Bhagavad Gita as it is. Like the name of the book he wrote is Bhagavad Gita as it is in the 20th century. Like it is considered as the most the stable version, like directly from the speaker itself. Like he has noticed that there are so many editions out there in the society which has been modified according to the author's indentation. So he has written directly from the Vedas and purports which are in our Hindu's literature. So his Divine Grace, Swami Prabhupada, born in 1896 in Calcutta. So in 10 years of his advanced age, in 10 years of his life, in spite of advanced age, Prabhupada's circle globed 12 times on lecture tours that have took him to 6 continents. So in spite of such vigorous schedule, Prabhupada continued to write prolifically. Like his writings constitute a veritable literature of Vedic philosophy, religion and culture. So he is the official author of Bhagavad Gita as it is first version. So like here you can see these are the total books written by Bhaktivedanta Swami Prabhupada, and this is the Bhagavad Gita as it is. So let's talk about the history of Bhagavad Gita. So the first version of Bhagavad Gita, I mean in written form, it was written 500 years before the birth of Jesus Christ, and 1000 years before the birth of Mohammad Prophet, and 2000 years before the word Hinduism coined. So actually many of you know Mahabharata, like the war between Kauravas and Pandavas. So the Bhagavad Gita is the part of Mahabharata, like it's the heart of Mahabharata. Like it is the part which favored the war, like it made the war happen. It is the one which started exactly before the war, and it helped the war to continue and end the Mahabharata. Like most of you know it, I guess. So Bhagavad Gita is also called Gita Upanishad. It is the essence of Vedic knowledge and one of the most Upanishads of Vedic literature. Like it has been mentioned in our Vedas, like one need not read all the Vedas present. Instead, if one reads the Bhagavad Gita completely and exactly receive the message from the speaker, then once it is equal to all the Vedas. So we know the speaker of the Bhagavad Gita is Sri Krishna, the Supreme Personality of Godhead. So I'll tell what is this later on, Supreme Personality of Godhead. So Bhagavad Gita happens is mainly a conversation between Krishna and Arjuna in a loop. We'll get to know what this loop is. So 18. So 18 means the number of books in Mahabharata. 18 means number of chapters in Bhagavad Gita, and 18 days is the 18 is the number of days Mahabharata was fought. So this is a sloka from Vishnu Purana. So it defines what a god is. Bhagavan, the Supreme Personality of Godhead, is thus defined by Parashara Muni as one who is full in 6 opulences. Opulences means characteristics. Like one who has these 6 characteristics up to 100%, then he is the Supreme Personality of Godhead. And Krishna possesses these characteristics: strength, fame, wealth, knowledge, beauty, and renunciation. So thus Krishna is called the Supreme Personality of Godhead. These are the 6 opulences of Krishna. So I told what is the term Supreme Personality of Godhead. Like we know so many gods, Vishnu, Narayana, Brahma, and so many others. So what is meant by Supreme Personality of Godhead? So here we have Krishna. Krishna he has expanded into 16,108 forms. Like each form is with one Gopika in Vrindavan. Like you can consider Vrindavan as heaven. In heaven, Krishna is in the form of 16,108 Krishnas. Each Krishna is with one Gopika. So the mother of Krishna is Devaki, father of Krishna is Vasudeva. So Krishna is also in 10,000 billion forms in Rasa Leela, like with every lady again. So what happened is there is a term called incarnation. Incarnation means replica, like continuous, like father, son, next, like that. So the first incarnation of Krishna is Balram. So Krishna first expanded into Balram. So then Balram again expanded into Ram, Lakshman, Bharat, Shatrugna, like Ramayana characters, the 4 brothers. Again Lakshman expanded to Narayan, and again this Vasudeva. Here we have Mahavishnu. One of the expansion of Narayana is Mahavishnu. So from Mahavishnu we have final incarnation stage. This is the final incarnation stage. So in the final incarnation we get this Vishnu, Brahma, and Shivaji. So these are all the gods, like according to Hindu literature, Hindu Vedas, they are all the incarnations in one way or the other directly related to Krishna. So Krishna has 64 qualities. So these 64 qualities defines he is the Supreme Personality of Godhead. And Vishnu has 60 qualities. Shiva has 55 qualities, like out of total 64. And Brahma has 50 qualities. And we living entities have 50 qualities, but not up to 100%. We have only partial 50 qualities. So this is like the definition of Supreme Personality of Godhead. So there is something like disciplic succession. Like a weird analogy is like Rakar is the mentor of Rahul and Rahul is my mentor. So similar way here Krishna, and Krishna is the mentor of Brahma. Brahma is the mentor of Narada, and so on. At 31st position we have Bhakti Siddhanta Saraswati, and he is the mentor of Bhakti Vedanta Swami Prabhupada. Like this is the visible succession from Krishna to Prabhupada. Total 32. You mean like the Bhagavad Gita's knowledge is being spread from Krishna to Bhakti Vedanta Swami Prabhupada. And Brahma is the first living entity the Krishna created. So Brahma is the first mentee of Krishna. So this is the disciple succession. Like it is mentioned in the page, like it is mentioned in Bhagavad Gita, this disciple succession. So let us talk about some small history of Mahabharata. So the word Mahabharatam comes from the name of the king Bharata. So the king Bharata is the origin for the word Mahabharata. So the king Bharata is from Kuru dynasty. So Bharata has 2 sons, Pandu and Dhritarashtra. So Pandu, they have 5 sons, Yudhishthira, Bhima, Arjuna, Nakula, Sahadeva. So they are noble and righteous. And Dhritarashtra 100 sons. The eldest son is Duryodhana. So how Krishna and Arjuna are related to each other? Like they are relatives in the material world, like on the earth they are relatives. So Krishna father is Vasudeva. And Arjuna mother Prita, they both are siblings. So in this way they are related. And also Arjuna married Subhadra. Like Subhadra is the sister of Krishna in that incarnation. Like Krishna is the god, but he has come he's exhibiting an incarnation on the earth. In that incarnation, like Subhadra is the sister of Krishna, and Arjuna married Subhadra. So from childhood, so both the Kauravas and Pandavas are trained by the trained in military arts by the expert Drona and counseled by the grandfather of the clan Bhishma. So later, when they grew up, we all know that Duryodhana challenged Pandavas to a gambling match, and Duryodhana cheated them. So the Pandavas went to exile. So upon returning from exile, the Pandavas rightfully requested for kingdom from Duryodhana, but Duryodhana told that they will not give any. They like the exact statement from Bhagavad Gita is that like he will not give at least one single foot of land to Pandavas. So the Pandavas decided like Krishna stopped Duryodhana from being like Bhishma knows that a war is going to happen. Like Bhishma also could not help. Like Dhritarashtra is a blind. Like officially he has like eyes blind, and he's also blind by his senses. Like everything is controlled by Duryodhana. So like Krishna did not listen to Duryodhana, and so now war seemed inevitable. So now the Bhagavad Gita comes into the play exactly before the war. Assume a war is being taking place. So everywhere, so all the Kauravas and Pandavas are assembled at the war scene. So the place of the war scene is Kurukshetra. So Dhritarashtra is in the palace. So Dhritarashtra so there is a person called Sanjaya. Sanjaya has superpowers. So Dhritarashtra and Sanjaya, since they are in palace, they don't know what going on the war scene at Kurukshetra. So Sanjaya, with his superpowers, can tell exactly what is going on in the war scene. So all the Bhagavad Gita discussions happens like Sanjaya is telling to Dhritarashtra. Like it is not really on the war scene. We are in the palace. Sanjaya is telling to Dhritarashtra what is exactly happening at the Kurukshetra. He can tell that because of the superpower. This is the loop we are talking. Bhagavad Gita is happening loop of talk between them. Dhritarashtra asked, the first verse start with the question of Dhritarashtra, like how did the war scene look like and what are my Kauravas doing there. Then starts the Bhagavad Gita. The Dhritarashtra question to Sanjaya. Then Sanjaya replies with the description of Kurukshetra. So this is the introduction and setting the scene of war. So like we can't discuss the whole Bhagavad Gita in the light. So let's discuss some important verses which I felt. So this is the verse, second chapter, 47 verse. It says, you have the right to perform your prescribed duty, but you are not entitled to the fruits of action. Never consider yourself the cause of the results of your activities, and never be attached to not doing your duty. It clearly explains, you can also understand that you have the right to perform a duty, but not with fruits of action. Never consider yourself the results of activities. And this is the verse 18 chapter 65th verse. So Krishna says, always think of me, become my devotee, worship me, and offer your homage unto me. Thus you will come to me without fail. I promise you this because you are my dear friend. So Krishna says that he is the best friend to all of the living entities. He declares to Arjuna. So why talks between Arjuna and Krishna are happening? So Arjuna assembled at the war scene. So Arjuna saw all the Kauravas. Like Arjuna became very emotional because he need to go to war. He need to kill his own family members. Like his own family members, he need to kill the very big grandfathers, like his grandfathers, grandfathers, and he need to kill them to win the war. So he thought like, how can I kill them? Like how can I kill my own brothers and my own family members and be happy after the war if I win? So this is the question that Arjuna asked Krishna. So then Krishna started Bhagavad Gita. So the actual Bhagavad Gita starts from the second chapter of Bhagavad Gita, describing like why Arjuna should fight. This explains all about Bhagavad Gita. So Krishna says that so he is the very dearest friend of all the living entities. He says to always think of him, become my devotee, worship me, and offer your homage unto me. So then we'll go to Krishna like without fail. Like I think you might not understand what is coming to Krishna without fail. So if I tell this now, then it might not get understood properly by you. So let's continue. So another verse, second chapter 20 verse. For the soul there is neither birth nor death. He has not come into being, doesn't come into being, and will not come into being. He is unborn, eternal, ever existing, and primeval. He is not slain when the body is slain. So Krishna says soul is Soul has no birth nor death. Like we are living entities, this is the material body, we have skin, etc. So skin has birth, pain, sufferings of the material world. So like the soul in us, it has never come into being. It is not a living being at all. The soul is always eternal, and only the material body is not eternal. The soul is always eternal. The soul is not slain even though when the body is slain. The soul is unborn, eternal, ever existing, and primary. So in 4.5, the personality of Godhead said, many, but so actually Arjuna asked Krishna, so Krishna, since you are saying you are the supreme personality of Godhead, so then why you have come to the world? Like why you have come to the earth? So then personality of Godhead said, so many births, both you and I have passed. I can remember all of them, but you cannot. O subduer of the enemy. Subduer of the enemy means Arjuna. So Krishna also had so many incarnations. Like we have seen 10,000 billion forms of Krishna and so many incarnations into gods. So they have many births. So Krishna can remember all of them, all of the births of himself and all of the births of living entities. But Arjuna can't remember. That is what making him the personality of Godhead. So 4.7, this is something important. Yada yada hi dharmasya glanir bharata abhyutam adharmasya tadamanam srijma aham. So whenever and wherever there is a decline in the religious practice, O descendant of Bharata, and a predominant rise of religion, at that time I descend myself. So O descendant of Bharata means Bharata is the king in the Kuru dynasty, and Bharata is the grandfather of Arjuna. He's referring Arjuna as descendant of Bharata. So whenever there is a decline in the religious practice, whenever there is a fall in religious practice, and predominant rise in irreligion, when there is a religion growing on the earth, at that time I descend myself. At the time Krishna comes himself from the heaven, like Vrindavan, to the earth as a living being. 4.8. Paritranaya sadhunam vinasanaya duskrutam dharma samsthapanadaya sambhavami yuge yuge. So to deliver the pious and to annihilate the miscreants, as well as to re-establish the principles of religion, I myself appear millennium after millennium. So we have seen that when there is a fall in religion and growing irreligion, so Krishna will come to annihilate the miscreants, as well as again re-establishing the principles of religion. How many times it may be? Like he comes, I myself appear millennium after millennium. Even million times he will descend himself to the earth. So 5.29, a person in full consciousness of me, knowing me to be the ultimate beneficiary of all sacrifices and austerities, the supreme lord of all planets and demigods, and the benefactor, and the well-wisher of all living entities, attains peace from the material miseries. So a person who believes he is full consciousness of God, Krishna, and the ultimate beneficiary of all sacrifices and austerities, the supreme lord of all planets and demigods, and all the well-wishers and the benefactors of the living entities, they will attain peace of all these miseries of the world. 6.5. So one must deliver himself with the help of his mind and not degrade himself. The mind is the friend of the conditioned soul and his enemy as well. So actually the Krishna refers the mind as the greatest enemy of oneself. So one must deliver consciously and correctly to the mind and should not degrade himself. So the mind is our best friend as a conditioned soul and is the best enemy towards as well.
Likit, I'm sorry to interrupt. I think we
Yeah,
have exceeded the time limit. Yeah.
The last one. So this is a video, small video. Please confirm if you did not hear the audio. Like since all this time, like have not been promoting any religion. So like I advise you to listen to this. Yeah, so the information here is from these links, credits to them. So thank you for listening, even though I have extended my time. Any questions?
Bro, why do like कब से when did you get that faith and all? Just personally asking as a personal question. Don't mind.
Like I didn't get you. Please repeat.
Like personally in all these ideas, like why and when.
Like, what was your main motivation for choosing this topic?
Mm-hmm.
Like this topic is the best topic I can choose for life. Like I can like delivering the best way, like very less preparation I can, like I need not dedicate more time to this, and this is what I am good at as far as I believe. So this is my topic.
Mm-hmm. No,
And
just
it,
one. Mm-hmm.
yeah,
Mm-hmm. No, continue.
yeah, so this is a very easy topic for me to proceed, and this is
Achha.
a good topic. Like I guess I don't say anyone here it is a bad
Mm-hmm.
topic. So
Mm-hmm. And just one thing, ki, like you put one Einstein quote and telling ki Einstein told ki Bhagavad Gita is this is na. So the same thing happens with Einstein in almost everything. Not just Einstein. They take a legend and tell this book, tell Bhagavad Gita or some Indian culture is so and so la, and tell that, and they use it as faith to, like, yeah, they use it kind of propaganda kind of thing. So be careful on whatever you see on internet. So, like, don't just
yeah, yeah,
blindly follow. So the problem is most of, yeah, such things happen in KGP also. KGP also takes like some legend. So KGP prepared some Indian calendar kind of thing, and they put a random chemist, some popular chemist, and they tell we should be thankful to Indian tradition and all and all. So because they did all things. So if you do a little bit of search, you find out that the scientist never said that. So this is not just in KGP. This thing also happens in many podcasts also. They say, okay, not Rabindranath Tagore told Heisenberg ki, he understood what uncertainty principle was properly, and he knew before and all. So if you again, when I did a search on it, so the search said ki, Heisenberg was not satisfied when he heard Tagore's ideas. So the problem is, like on internet, every culture tries to promote its culture through some fake incidents or events, or tries to create yeah, proves that this is something super powerful, just blindly follow it. So I think one thing what we should do as readers or someone who wants to seek a, like, I think what we all want to find meaning in things now, like, so we always feel like we have a very good rich pleasant feeling when we try to understand life from a philosophical perspective. So but the only thing I want to suggest and ask or request, whatever, recommend, or if you want ki, if you want a philosophical perspective, make sure you don't get hooked by whatever people say on the internet. Like, try to personally think what really it means. Like, why is this person saying so? What did happen? If you really read, like Einstein said Bhagavad Gita, try searching and see why did Einstein say, why did Einstein go to Bhagavad Gita. If you see, he never read. Even when I was a kid, a prof told me Einstein wrote related equations from reading Gita. Such things are really randomness. So it's not that Gita doesn't affect. Many people found their own meaning, but that's different. So just a request or recommendation ki, try to like search everything critically, and do your own research before saying something. Yeah. Try to do your own research before, like, catching on some idea. So yeah, that's all I think. So
yeah, yeah, thanks for the
that's
session.
otherwise problem is say, like, this affects your own mentality also. Like, you will start believing whatever someone says with, this is the proof. So you will lose the critical ability of questioning in your daily life. So, and I think, yeah, that kind of indirectly affects you also. So they basically try to question, so, and see, does it make any meaning. So Carl Sagan's Balloony Kit. So when you are free after this, try searching Carl Sagan's Balloony Kit बोल के video, or you can clearly search Carl Sagan's क्या dragon story बोल के, about what's scientific or what sort of finding, what is the thing that you should believe in. So yeah, maybe you should try that. Yeah, that's it. And it's anything more than, yeah. Okay, sorry.
Yeah, fine.
Yeah, so I'll go next.
some big shoes to fill now. Utsav, be careful.
Can we have a 2 minute break or something before this, if you want to?
Yeah, I'm fine with it.
Baki do?
Okay, fine.
Cool.
Let's meet then at 11:10. It's 11:08 right now, so meet at 11:10.
Small break.
So can I start?
Cool. Let's start.
Yes.
So hello everyone, I'm Utsav Mehta, and today I'm going to speak on web scraping using Python. So the basic question: what is web scraping? Now there are many websites out there, and web scraping is basically extracting structured data from those websites in an automated fashion. Now those data can be used to store in one of these formats, or maybe we can implement some sort of functionality with it. So this is what basically web scraping means. So how will we do it using Python? Now Python has some modules like Beautiful Soup, Selenium, and more to support this. Okay, so we'll use Python, but how? So let me give you an example. Now this is Amazon.in, and this is a keyboard, and its price is 8990. Now let's suppose I wanted to buy it, but the price is too high. So uh, I will buy it if the price goes below 7000. Now one way to proceed will be that I every day visit this site and check if the price has gone below. But we are too lazy for that. So we will use web scraping to do this. Now, how will we do it? If I inspect this, yeah. So you can see the price is stored in a span tag, which has the ID of price block R price, and there's a class, and this is the price 8990. Now, the same span tag you can see here. So I'll use web scraping to find the exact value of this price. So this is the code, but I won't go into much details. This is basically the link to the Amazon site, the keyboard, and this is the main line. So what I do is that I tell Selenium that from the browser, go and find an element by the ID of price block R price, which is the same ID, and I store it in a variable called price. And if I was supposed to print the price, this same variable, it would be the same tag. And next I tell it to print the price of print the text of the price. So this is what is the output in the terminal. So this is how web scraping works. Now if I am supposed to give you a more deep example, now this is Zillow. Zillow is a renting website, and it has it has all the homes in a particular area that are available for renting. Now this is the list of the homes available, and let's say I have a client, and he tells me that go and find all the homes in a particular area and give me the list. So that is too cumbersome for me to go and check all of these. So I won't do that. I would use web scraping. So what I'll do is for every tile you can see here, there's a price, there's an address, and there's a link associated with it. So I'll scrape all the data from this website and I will give it to the client. Now this is the code for it, but again I won't go in details. One of the key lines is this, which means that from the website you should find all the tags with the name A, which means anchor tags, and whichever class of this list card image, and for all those tags get me the H reference attribute, and this is stored in this dummy links list. Similarly, I do it for the addresses and I do it for the prices. Now, so boom, all the tiles that were there, my data is stored in this lists, and now I just need to figure out a way to give it to the client. Now again, I use web scraping for this. So what I did is I created a Google Forms which has currently 0 responses, and it has 3 questions like what's the address, the price, and the link to the property. So I'll open this forms with my code, and I again use web scraping to enter all of the data from all of the scrape data from this Zillow to the form. So if I go ahead and run the code, what you will see is a browser will pop up and all the fields will be filled automatically, and the browser will close itself, and then it will again do it for all the tiles that it scraped. So as you can see, everything is automated, and I don't have to do anything except to run the code, and my whole job is automated using web scraping. Now the process is too long. I will stop it because it will take too long. But I can show you the forms, and it has 3 responses which were given by my code. And so boom, I didn't do anything. I just ran a code. My code went and listed all the tiles from Zillow and gave it to my Google Forms, and maybe now I can create a Google Sheet out of it and give it to the client. And so my job is completely automated. So having said that, I assume that you guys will be too excited to start web scraping, but I didn't hope that you guys would believe that it will be too easy, because it's not, and there is something known as a law. Now in the past there have been cases where big companies sue other companies for scraping their data. So is web scraping legal or not? So it's legal unless we use the scrape data for a commercial use, because anyways I can always go to Amazon and scrape all the data and create a similar product, but that won't work, right? Once Amazon finds that I did this, it will come and sue me. So this is not how it works. The thing I did in all of these was for personal use, so that's not controversial, but you cannot use it for commercial use. But now once I told you that you can be sued, you might be concerned that how do you know what to scrape and what not to. So there's this robust.txt to help you. So if I go to, let's say I go to Udemy, and just a second. Yeah, in the browser, I'll type /robots.txt. And this is what pops up. So this is the list of all the things that Udemy disallows me to scrape, and the list of things that it allows me to scrape. So every popular website out there will have such a robots.txt, and it will list all the things that are allowed for me to scrape and not allowed for me to scrape. So yeah, this was all about web scraping. Thank you.
Thanks, Utsav. That was nice. By the way, like the robots.txt file, right? It is just a suggestion to the crawlers. So it is not, they don't really have to sort of comply. It is just that, like, it's sort of, I don't know how to put it. It's like they can if they are ethically responsible, right? So, yeah.
Okay.
And another thing, like another interesting thing I remembered when you talked about Facebook scraping, right? So I had an idea a while back. Me and Palkit were working on it. We were actually trying to scrape all the confession pages of KGP. So we thought it could be some sort of interesting data, and we could do some interesting things with it. So yeah. So if anyone wants to try that, you can.
An interesting question, I think, is I think this is more privacy, but what happens if a website does not have a robots.txt? What are you allowed to scrape then?
Yeah, we are always allowed to scrape unless we use it for commercial use. So.
Yeah, I think, or I was wondering, like, if you were ever to come up with a law, or if you were to come up with precedents for scraping, how would we like put them into implementation? Like, how would you prevent people from scraping certain things? Do you know about this concept of user agents when it comes to browsers when you scrape?
Yeah.
So I read this very interesting, I think it was a blog or paper, that there are, so when you send requests via Selenium, so like for when you scrape via Selenium or you use Selenium instead of using a human, some browsers can actually figure out if you're using Selenium or not, even though it tries to mimic exactly what a human is doing. Which is interesting because if you can figure out if someone is scraping, then you can obviously block those kind of requests.
Yeah.
Then how do you scrape effectively when website owners can figure out? I think this is
Can you fake user agents, by the way?
Yeah, very easily. You just have to pass
Yeah.
a header.
Python has a library
Yeah.
Then what about
Public
capture?
headers thing.
Like,
If
no,
you
but,
guys
but,
see
they,
here,
but they don't use user agent. They use something else. Using user agent would be very simple, and I can always.
No, what about captcha, Mughal? What about captcha? Can you not use a captcha to prevent scrapers to scrape your website?
Actually, there are a lot of captcha solving websites that can solve, say, 1,000 captchas for $1. People use that often.
Even for like
and
captcha.
So, like once I got a freelance offer, like one guy wanted to do a business where he was like aggregating data from several websites. So the task was pretty simple, but then I turned down because of this legal issue. I did not want to be sued just for writing code.
Yeah, so I was working at a startup, so they were also like scraping all these old government websites. They were downloading their PDFs. So even I was at that point, I was not really sure that where is it on the legal, how is it legal and stuff like that. So I always thought it is sort of like a gray area. So yeah, and they also were using captcha solvers. Like it is pretty easy to solve a captcha even. I'm not using a service, just writing a program to solve it. So.
I think new captcha, the 3.0 protocol, that uses like your browser fingerprints to, right? It doesn't use that. you don't need to solve anything. So there are ways of like how you can behave or your move your mouse like a human, where you would take breaks, make random movements, and break the latest version of Google's captcha. I think Ishan, is this what you were talking about? The yep,
Yeah, exactly
the
that.
ability to recap.
You can
I think
accelerate
it
and
was
maybe
week.
overshoot.
I think this
Yeah,
was
sorry,
week
go on.
3, wasn't it? Anyway, so you can do these kind of things with browsers. This is weird. Yeah, Divya, you were saying something?
Yeah, I was saying about the legality of it all. Like, if it's public, if the website is public and accessible to everyone, is that even illegal if I use a computer program to scrape the website? Like, why should it be illegal? It's public, right?
Rakar had a very good argument for this. Rakar, are you there?
Like, it could be
हाँ हाँ
unethical,
अरे
yes,
it was
but
actually what we tried actually हमारा at Nira only we planned to scrape all the public slacks. तो public slacks are slacks जिनका invitation link is public जैसे Meta KGP is public slack ना. So we tried for these two slacks, Gopher ka Slack and CNCF ka Slack. So to install basically, but if you wanted to scrape and provide a search interface for that, what we planned was we had to install a bot. So when we said in both the slacks ki please install admins please install this bot, they said ki nahi yes this violates our user privacy. Do you your user privacy also doesn't user privacy policy also doesn't speak anything about it. You are breaching privacy, will not install. So both the popular slacks said that. तो बेसिकली आई थिंक पीपल का ये है क्या व्हाट इज पब्लिक एंड प्राइवेट उस इस इंटेंशन पे होता है कि who are they intending to put the message. So for example when they put in Slack they intend that only be part of this CNCF community or Gopher community will see. So they don't want it to be easily available like a Stack Overflow answer or something. And if they put it on their website or Facebook, it means they want to broadcast it to the world. So for such data I think people won't yeah, fight that oh you can't scrape. But for data which is intended to only a small group of people like get angry and say this is privacy, this is
yeah,
violation
that
of
that will
privacy.
get they'll make
Mhm.
people angry definitely, and it'll also be unethical. But at no point it's illegal. That's the difference that I wanted to make. See, even
Uh-huh.
if let's say you use your account, right? I can still use my account's token and access token and everything to download things from that Slack channel. I can do that always, right? Or I can request a copy of the data of the Slack channel that I'm in. Uh,
Mhm.
so the point is like it's unethical, but it's not illegal. That's so it's upon the developer where that developer draws the line. So yeah.
Mhm.
But the issue with it being unethical but still legal is, in case someone does this, or in case someone violates, or I wouldn't call it violate, but in case someone does this unethical thing
Mhm.
and it goes to law, and since there are no precedents, what happens? Do you go to jail for
That'll
it?
be
It
interesting.
sounds legal, except nothing of the sort has happened. So, like, you're
Yeah, but
really like depending on what the judge interprets to be legal, right? Because there's nothing that says it's legal either.
yeah,
There are
in
no
many cases they are just given a warning that don't do this again, and they are
Yeah,
yeah
there are many big companies who didn't get any kind of jail time or anything, just a warning.
yeah
An
And
example
then
that comes to
and then
mind
and
is,
then Groovy got shut down.
Sad trip groupie.
but Groovy was shut down because of like valid. I mean, I'm not saying the
Yeah,
reasons
yeah.
are valid, but it violated a certain terms of policy that was written, and you could establish that.
No,
But in
like
this case,
Groovy was making money off YouTube. Like they were having their own paid stuff. So I think that was the one
Yeah, so
targeted by
now
YouTube.
if you scrape Amazon and put it in your website, you are not only stealing page views, you are you can sell that stuff yourself also. So that money you are also stealing money from them. So it's kind of
Amazon
similar.
very strongly has issues with these scrapers. In social computing, we had this paper where it discussed like why Amazon does not want you to scrape prices is also because some people have tried to reverse engineer the algorithm they use to price stuff. They don't want you to have that data because they lose their edge if you figure out how Amazon's dynamic pricing works.
Interesting stuff. Yeah. I think, yeah, like a social computing project or that course should be very more popular, I guess.
Cool. This was really fun. Utsav.
Thanks.
Who's next?
So I am next. Let me present my screen.
Nitish said it's illegal content, do not record.
Yeah, it's pretty illegal, I would say. So you could stop recording.
We can edit it out, I guess.
What's the topic, by the way?
It's Google Dorking.
Oh, it's not illegal. Go on.
Last part
As long as you don't want a job in Google.
Yeah, I don't want. Yeah, I hate pretty Google pretty much. So let's start. So I'm Nitish. I will be talking about Google Dorking today. So as you know, Google is contains the largest database of information. Let me just confirm my slides are visible, right?
Yes.
Yes.
Okay. So as you all know, Google, it contains the largest database of information. Just to give you the magnitude of data it processes every day, like it processes over 20 petabytes of data, and I've taken this data from a random website, so don't focus on the magnitude. But still, you see, Google and Microsoft combined process over 2,100 petabytes of data, which is approximately 1.2 million terabytes. Anyways, I just wanted to lay it out. So how does Google know what to serve? I mean, how does it cater to the need of every user out there? So it makes assumption like popularity, how freshness of the topic, what is your search history, your location, the device you use, like it is a laptop, a PC, or a mobile phone, etc. The freshness of the topic, and so many more. So this everything from is done from the Google side. So is there any way by which we can tailor to get we want a specific thing, some information which are specific to our needs. So can we make that happen? That's where Dorking comes into picture. So what's Google Dorking actually? So it's pretty simple. Google Dorking is basically advanced Google search where you use certain kind of operators which is specified by Google. This is a Wikipedia definition. I quite don't like it, but yeah, it's apt. Like Google Docking is also known as Google hacking, but because primarily it's used for like security purposes only. Let me. These are some use cases. Like I mainly use it for piracy. I will be frank. Next one is finding a specific type of files like books, research paper, etc. This is mainly piracy only. Yeah. Next one is it's uses a hacking technique. So it's a very broad topic. And OSINT, if you don't know, it's open source intelligence gathering. So I will talk about the works. Let's say whenever I type my name in Google like this, whenever I type my name, I'm pretty annoyed. Like it always gives me the Chief Minister of Bihar. I hate it. So how do I tailor it to give like what I want? So this is a pretty basic dot. Like I type Nitish Kumar and minus politician. I am basically saying Google that I don't want anything that has to do anything with the keyword politician. Also, I don't want anything to do with the keyword chief minister. I've included it in double quotes, so because of the space in between. Also, I want it to include this IIT Kharagpur. You can see it gives pretty good results, like IIT Kharagpur, Nitish Arora, like IIT Kharagpur, like this kind of thing. Next is this wildcard operator. How to make it's a wildcard operator. You might be pretty familiar with it from the regex. What it basically does is it will give you anything like how to make what sushi, how to make a website. It will give you anything. The next one is curl or wget. This pipe operator. It not to be confuse it with that Unix thing. It's not piping and redirection. It's OR operator. If you type this curl pipe wget, or you could type curl or wget, it will serve you the pages which contains curl or wget, either curl or wget. Next one is this site. You specify any site as linux.org file type PDF. This is the most important of file type. It's most widely used also. So this site arclinux.org, it tells Google that I want everything to do with this site, and I want every file out there. Like let me just show you an example. Let's say I want this. So this our pointer site. I want everything that a PDF document from a whole other website. So it serves me right the PDF file. It's a cb.pdf. Okay, it's taking too much time to load, so I'll just skip this. Maybe if it will load, I'll show you. Next is this site. This basically basically what it does is searches for keyword. Every keyword, the keyword name is specified here, pipewire in this from this site. Next bit is in URL. It basically search the string from the URL, whatever matches from this particular site. Like if we give a keyword here, it searches for it searches that keyword within the URL schema within that site. Next is in title. It basically searches whole web page, any term actually. This is a cache. This what it basically does is it shows this cache shows the last time Google crawled that page. If I do a cache and any website name, it will show the last time which Google crawled that page. I basically use Wayback Machine for this. It is a way better choice. It usually gives like 10 or 15 years, I don't know, back. You can access the site from 10 or 20 years back. You can look at your site how it seemed at that time. Let's say I'm doing dicing and I want a 19 to 20 resolution image pixels. So I will specify the site as plus. This is a wallpaper site. I want a wallpaper from this. Image size is this. Let's say I want web security. This is a search term. I want RSS feed about this. You could just do this. Most of the thing about here I have explained. These are some more operators like maps, books. These are pretty self-explanatory, so you could understand this. This is the juicy stuff. So mainly I do it. This is my primary use case. I do it for piracy. I'm not gonna lie. Anyways, let's give. So if I do this index of slash Hollywood, you could see all the movies. You could download everything. This is an open FTP server, so you could download any movie from this. If I go back a directory, it is movies from 2020. So you could see a bunch of movies. Anyways, if I go back a directory, you could see you could search by like a year also. You could download any. Sorry. You could see Bollywood, Chinese, any kind of movie you can download. That's why. So this is a pretty large data to work with. So if you want a certain kind of specific movie, so you could just type like index of Rick and Morty. It will give you a whole season of index and Rick and Morty. I've tried all this works, so you can try this. Next, if you want software like cracked or something, I don't know, you could just write this in title. It basically searches the title of the page, whatever if there is index of, and then you are specifying I want an exe type of file and whatever software you want. If you want an ebook, you can write type this doc. If you want music to download, you can do this. Comics to download, you could do this. These are pretty kind of same thing, so I'm not going into detail much. These are some of the fun things which I found. You might have heard about Zoom bombing meetings, where any person randomly enters into a Zoom meeting and some crisis other. This is the center for this. I've tried this actually, so it doesn't work most of the time. Like you would get an expired link, but if you are lucky enough, you might get one. These are some sensitive. I will not talk about this anyways. So this is Google Dorking is also known as Google hacking. So this is its primary use. Like if I do entitle webcam XP5, I have actually a video about it. It's a 25-second clip, so it might not. Let me show it. It's visible, right?
Yes.
Yep.
Yeah, you could see it's a live feed of the camera, like, and it's pretty stupid, like it's not logged. They could have provided at least a login ID and password. So, but it's open. Anybody could access this. You could see it's a live feed. You could see the car coming from here. Here you could see the river flowing. So just I wanted to point out this. This is a live feed. I don't know if it's illegal or what, but anyways, I'll continue. This is also the same thing in URL. It's a live applet kind of thing. It's the same as this webcam thing. Then in title index of in URL FTP, it basically searches for any open FTP ports, like, and you could access any of those. Like basically, some of them are like login password protected, but it is easily like can be brute force or something. Or if you try default password like admin password, etc., it will open most probably. I've tried this, and it usually works. This is a dork. It's pretty sensitive data. Like I have a bunch of. I've tried this actually. I've used Tor over VPN for this, just to be safe. So I've tried this, and I've got a bunch of data like email IDs and password, like real password. I will not show this here, anyways. And this is pastewing.com CVV. It also searches for credit card details and etc. This also I've got it, but as I tried this, I found most of them are like fake. Like Pastewing usually doesn't allow sensitive data to be on their site, like for at most 2 days or something. They remove it. But if you're lucky enough, you might get one. I have some of these credential, like there is. If you want, you could tell me at the end. I could show you. I'll not say here. Anyways, this is especially my admin page. It's usually, as far as I know, I'm not an expert in this, but as far as I know, it is used for like SQL database management or something. It's a control panel thing, same as this. It is used for like website controlling or something. Anyways, I just wanted to point out that this is a very like vast field. There are tons of door card there. Like if you go into this website, GHDB Google Hacking Database, you could see every day there are tons of dorks being added. Like 27th is today, I guess. Or you could see there are tons of dork, like pages containing local portals, web server deduction, various online devices, file containing juicy info. You could try some of these. Anyways, I just wanted to point out it is pretty vast, this field. Anyways, I will not talk about like prevention robot.txt. It has been like extensively covered in the last Utsav slides, so I'll not talk more about this. I just wanted to like most of the time when you deploy a web server, like it's like pretty secure. Like the company who is providing you the server are pretty secure. But anyways, if you are hosting your own server or etc. something which is exposed to the internet, I will really advise you to use those doors on your own site. Like if you don't, somebody will. So it's better to like check yourself and so always encrypt your sensitive information, and that's a given. At last, I wanted to point out, like if you hate Google like me, also it's pretty ironic I'm using Google products right now. Anyways, if you hate Google and you want to use like DuckDuckGo, if you're using DuckDuckGo, there's pretty neat feature in this called Bang. Like if you give a exclamation mark and G and write your query, it will directly redirect you to those Google website. Like if you write exclamation G and search query, and if you want to directly access Amazon, like if you and then you could write like exclamation A and like if you're searching for camera, then exclamation A camera, it will directly redirect you there. So yeah, that's a pretty neat feature. And also this docking is not like specific to Google or something. and you could use it on like any search engines. Uh, yeah, so I'm pretty much finished. Thank you, I guess.
Thanks, Nitish. That was quite interesting.
Yeah, and also not illegal.
Yeah.
Yeah,
Yeah.
I thought about that feed.
So
Some
yeah.
parts were
Thought,
kind of illegal, but yeah.
yeah,
So there's a
I mean,
there's a website, I don't know if you know it or not, called Shodan. Okay.
yeah, Sotan, I know it.
Yeah.
Oh, that one.
Shodan is a search engine for such kind of
Yeah.
things.
It basically exposes everything that is like port forwarded on the internet.
That's
Whatever is
how
exposed, yeah.
like botnets. Most botnets come from Shoda.
Yeah. Hmm.
it's funny. It's funny that you think this is illegal when it's Google who's actually doing the scraping.
Yeah, no, I've heard somewhere like it sounds to me like pretty like I've not shown you the credential dumps. Like I have a list of
Yeah.
credential. Yeah,
By
like
the
credit card and details and stuff. So those are pretty illegal. So I'm not.
yeah,
Those are
Yeah.
extreme stuff. Like,
So
so I'm not showing
this
those.
once happened
uh,
that
like
last year, the ML class was going on and there were a lot of students online and we were mostly asleep. At that time the professor shared his full screen and there was a big text file known as credential.txt where his ATM pins and stuff were listed out.
did someone screenshot it?
Somebody did, I think.
Nice.
Of
रिकॉर्डिंग
course.
नहीं हो रहा था क्या रिकॉर्डिंग
Of course. Someone did.
By the way,
याद नहीं।
this reminds me of little fun fact like Google Docking. If you try to Google Doc credit card numbers, Google will block that search and show some like warning or something. I tried it once.
Yeah, I did. It didn't for me at least. I used Tor and
I think it was ATM card pin or something. Like it was very specific.
Yeah. Anyways.
Yes. How did you get interested in this stuff? Like just to fuck around or?
I basically knew about Linux from these only web security and stuff. So I play a lot of CTF and etc. So I'm pretty good with some of these.
Nice.
This was like really cool and a lot of new things. Like I think I know what I'll spend my time on for the next some time.
It's pretty addictive, but then after some time you will like
Yeah, I
feel
would
bad.
just advise to use Tor or VPN etc. Just to cover your tracks. It's not good to leave your tracks around.
Nah, man, I'm gonna use my public IP and post it
Yeah,
everywhere.
that's pretty bad.
The benefit of living in India is that everyone is under an ad, so one IP is shared by at
CG
least
NAT.
10,000 or at least 1 lakh people.
Yeah, side note, I discovered this very recently that a lot of Indian ISPs use CG NAT, categorized NAT. So you're behind two NATs. So there's no point of knowing someone's public
Safety
IP.
plus plus.
Not
Privacy plus
safety
plus.
plus plus. They don't want to spend
Yeah, I
money
know,
on
they're lazy.
IPs for
And,
people.
And I contacted my ISP for some configuration issue. I am 100% sure they don't know how to log IPs or anything. At least local broadband.
I got to know this because I reached out to my ISP for like checking if they can give me a static IP.
Oh yeah, I
Turns
contacted
out,
my too. I had to
yeah,
pay
it
2,000 rupees
costs
for
way
one.
too much.
So
I
it's
mean-
like the whole of India is behind an app.
Yes, mostly. Nearly every ISP does that.
So the CG NAT works like this. So there's one NAT between you and your ISP, and there's another NAT between the ISP and internet. And
Okay.
that range of second IP addresses is 100.64. It seems like a normal like public IP range, but 100.64 IPs are also NAT IPs.
Doesn't it like this should be a part of the AS, right? It should not be NAT. It should be what we call AS, right? So
No idea.
I don't know. I think it's called CGNet on. Like I had to pay 2,000 rupees per year to get a static IP.
and just
Actually, a very nice deal. 2,000 per year is not bad.
No, add to that VPN costs. because this is static IP. I can't do stuff anymore on it.
Is it a IPv4 or IPv6?
V4, V4.
I think IPv6, at least Tata Sky Broadband is giving 50 IPv6 addresses to everybody.
Oh, nice. I think the Airtel, I mean the SIM card ones, IPv6 address are public too.
Oh. But Geo doesn't.
Geo sucks.
Recently, I shifted, so either Geo and Geo Fiber doesn't
Yeah, Geo
have
sucks.
static IPs. They don't even let you pay for getting a static IP.
Yeah, Geo sucks 100%.
Bro, Nitish, why do you hate Google? Matlab, just curious.
I'm a like a privacy friendly person.
Aha, duck duck go.
Yeah. So I whenever I can I I don't use Google products. I mainly use open source everything. I try to switch. So yeah.
Why use Chrome?
Yes.
Yeah. It's for like I mainly use Firefox, but for presenting this and all, like while I was doing research or something, it sounded good. Yeah. Like it's fast.
You can use de-googled Chromium, I think.
Yeah, I use it on phone. Yeah, I have this on this piece too. Actually, it took 8 and 9 hours. I told some 8 and 9 hours to compile, but yeah, this is I use this anyways.
Okay, I think we should move on to the next topic.
Bro, 11:50 है, we can 2 parts का plan था.
हाँ, 2 parts का प्लान था. 2 ही टॉक बचे हैं अभी. कर लेते हैं खत्म.
कल बहुत ज्यादा हो जाएगा नहीं तो.
एक तो कर लेते हैं मतलब.
आज 9 है, कल 8 है शायद. या नहीं, कल 9 है, आज 8 है.
ओके.
कर लेते ना, दोनों हो जाएगा आई गेस.
चलो. स्पीकर सर ओके.
हाँ मतलब
साहिल शुगर विद द
कोई तो बोला
प्रोसेस.
था ना कि कल उसका प्रॉब्लम है शायद.
या अनुष्का का प्रॉब्लम है.
Yeah, can I do it today? The talk.
Yeah, sure. I mean, switch करना पड़ेगा या फिर schedule?
No, I think Ritwik was first.
Yeah, Ritwik, then you.
Yeah.
Okay.
Yeah, hello. Am I audible?
Yeah.
Yeah.
So, let me share my screen. Okay. So I've just chosen lots of people have chosen very interesting topics. My topic is not so very interesting. So today I'm going to be talking about this manual image manipulation. Like so we know that we can do basically image manipulation in 2 ways. First one is the GUI based, like you can use Adobe Photoshop or many other online softwares and stuff. And the second one is you can directly access all the pixel information and then you can modify it as per your requirement, such as in this HTML5 canvas and OpenCV and all these are available. And so this is not a strict boundary. There are a number of tools which fall in between, like in between the either of the two extremes. So image 101, basically each image has 3 different parameters: the width of the image, the height of the image, and the array of the pixels, which is just a linear array of size, width into height. And generally in the RGB model, each pixel has a red value, green value, blue value, and an alpha value. So this generally varies from 0 to 255. And in some applications, the alpha value varies from 0 to 1, and in others, it varies from 0 to 255. So I can just show you a demo. Like, so you can see I've got a sample image here. This is the width, this is the height, and all this. So this white color I have like you can see this red value, blue value, and green value. And this sort of greenish color, you can see these values, all these values. So basically, this pixel has red value, green value, and a blue value, and that's it. There are some other models like CMYK, HSB. So these are basically the same, and all are basically equivalent. They're basically a linear mapping. So when you think of image manipulation, it can be like thought of as a mapping from the original pixel to the like the modified image is a function of the original pixel. So you are basically taking the entire linear array of the original pixel and you are mapping it to something else like some new pixels. And depending on what this like modification function is, you can apply lots of different filters like blur, sharpen, and many other things. So the first thing is basically like identity mapping. It just sets each pixel to each of its like as it was in the original image. So it can be thought of basically as a simple copy paste of the original image. Like so let me show it. It's not very interesting. So but doesn't have to take a look at it. So all I'm doing here is this is my original image and I am mapping it from like one to one corresponding this identity mapping like from here to here, from here to here, same to same. You can see I've got this original image here, this modified image here. I'm accessing each of the like original image pixel and I'm setting it to the modified image pixel. So this is basically a copy paste. So not very interesting. So but this is a fundamental like image mapping. The second kind of mapping is grayscale mapping. So what it does is that it looks at RGB values of the old image and it sets it to the average value. And it basically converts the original image into a black and white image. Or instead of taking the average, you can take the maximum of the values. That will also work. And this maximum is sometimes called the brightness of the image. So here I've got another example. So you can see I've got the same image and this is the original image, this is the grayscale image. So I'm accessing red values, green values and blue values and I'm setting it to the average value. And this average value is going to be the same for the like red value is also the average, the blue is also the average, the green is also the average. So that is just a grayscale color. I'm setting it for the each of the pixel in the modified image. So that results in the grayscale image, like from RGB to grayscale. The third kind of mapping is something called a binary grayscale. Suppose an original grayscale, like the original black and white, you have 0 to 255 is 256 options, but in binary grayscale you have two options, like either black or white. And there is a threshold, like on the depending on the where your threshold is, you can like choose a particular pivot point and change your like nature of the your image. Like so, let me show it. So you can see this is my original image, and this is actually the 0 threshold, and this is the 255 threshold. So what is happening is that if the average value of this pixel crosses above a threshold, I'm going to color it white, and if it falls below the threshold, I'm going to color it black. So this is a binary grayscale mapping. So you can look at it. And what is actually happening is that you are reducing like the number of data that is actually required to store this image. But nevertheless, you are like preserving the original quality of the image. I mean, not quality, but like more like features of the image. So this is a particularly nice mapping. You can look at. And similar to the binary mapping, you can have like ternary and higher order grayscale mapping where you instead of using 0 to 255, you can use more number of options like 0 to 128 to 255 and more number of options. So that is also possible. So the fourth kind of mapping is this convolution based mapping. So convolution matrix is basically a matrix, and you are taking the previous pixel. You are also not only looking at the original pixel, you are looking at the neighboring pixels as well, and we are setting a particular pixel value to like a weighted sum of all the neighboring pixel values as well. And depend you can look it up. This is a very popular topic, and this enables us to employ many popular image filters such as blur, sharpen, and other things like edge detection, Gaussian blur, and many other things. So let me show you one example. So this is the simple blur algorithm. Like you can see, I'm taking the average of all these neighboring pixel and the original pixel as well. So I don't know whether you can see it properly or not. Here is the original image, and it looks quite like normal. And on the right hand side, I have this blurred image. Like each pixel is taken as the average of all the 9 neighboring pixels around it. So you can see that this has a nice blurring effect. So all this, there are many other convolution matrices available, and you can also take like increase the size of the matrix, and you can get more blur and all this stuff. So that's another interesting thing. And there are also sharpen and many other things as well. And another thing you can look at is like this merging two images together. Let's suppose you have a number of images, and we're trying to pick up common features from this all these sets of images. So what we do is we
Ritwik, we can't hear you. अच्छा इसका नेट गया है.
Can someone ping him in Slack and ask him what's going on?
Yeah, I'll just call.
Hmm.
ओके जब तक वो आ रहा है क्वेश्चन था ये प्रोसेसिंग सॉफ्टवेयर व्हाट्स दैट
As far as I know, it's like Java-based software that is used for like coding computer graphics kind of things. Not really computer graphics as in video games and stuff. Like you can draw 2D and sometimes 3D graphics. That's And there is a
For
counterpart.
visualizations, mostly it is
Yeah,
used.
visualizations. Yeah.
Like mostly journalists and like graphic journalists, they use such kind of softwares to do their visualizations and all.
Oh, nice.
There is a web counterpart of that is called P5.js that works in the browser.
Also, Ritwik isn't picking up his phone.
So instead of waiting, I think should we start with the next speaker?
Yeah, there's only one left for today.
Yeah, Ananya.
Anushka.
Sorry, not Ananya. Anushka, yeah.
Yeah, I'll present. Hope it's visible. Hi, I'm going to talk about some basics of deep learning and some applications that I found pretty interesting. So I'm pretty new to this, so forgive me if I make any mistakes. So to understand deep learning, first we have to understand what artificial neural networks are. So neural networks reflect the behavior of the human brain and allow computer programs to recognize patterns and solve some common problems. So let's look at the structure of an artificial neural network. It comprises of node layers. So it has an input layer, a couple of hidden layers, and an output layer. So each of these nodes are connected to one of the other nodes through a particular weight, and each node has its own threshold. So if the output of an individual node is above the specified threshold value, then the node is activated and it sends data to the next layer. Now, if it is not activated, then no data is sent to the next layer. So to understand this in a simple way, this is an example. So this is the most basic neural network. It has just one input layer and an output layer. So suppose it is to determine if I should eat a chocolate or not. Now, the inputs I've given is that the cost of the chocolate should be less than 20. It shouldn't be a dark chocolate, and it should be daytime when I'm eating it. Now, suppose I really hate dark chocolate. So I will weigh that particular one as 5, and then cost, and then the time of the day. Now, I'm taking a random bias to be 5. So for the output to be 1, this particular equation should be greater than or equal to 0. Now, I've taken a sample input as 1, 1, 0. That means the cost is less than 20. It's not a dark chocolate, but it is nighttime. So when I calculate it, I get 3, which is greater than 0. That means I should eat the chocolate despite the time of the day being time being night. So this is just a simple one. For a more complicated one, this output is used in another layer and so on to make it more complex. So when we were little, we did not really understand which number is 0, which is 1. But once we were taught that, we could differentiate no matter what the handwriting, whose handwriting was written in. So the same applies for neural networks too. They have to be trained. So if we take the same example of handwriting recognition for numbers only, this would be a training data set. So this would be fed as an input to the neural network. And initially, suppose we just put random weights and a random bias. So we will get some predicted output value, which would be some predicted number. Now we already know which category it belongs to. So we calculate the loss function. The loss function in the end is basically the measure of the error between the predicted output and the actual output. So we keep varying this particular thing until we get the loss function to be a minimum. And then we can give in any input and we will be able to tell which number it is. So what is deep learning? Deep learning attempts to mimic the human brain and enables the system to cluster data and make predictions with incredible accuracy. So deep learning is basically a neural network with 3 or more layers. So it is sometimes also called deep neural networks because of that. So some interesting applications which I found were image recognition. So this is one of the most common applications. What is image recognition? It is basically a task of identifying objects of interest within an image. So for example, a car over here, a cyclist, a dog, and so on. So as any neural network, first we have to train it. So we use a large data set of many examples of each image class. So suppose we want to find out the difference between a dog, a fish, and a cat. So we have an image class for a dog, fish, and cat, and then the neural network trains to identify them. Then this particular model is tested using some extra data sets to make it more and more accurate. So each layer of node trains on the output of the produced by the previous layer. So it starts off pretty simple, and then it builds up in the successive layers that can identify more complex and detailed features. So to understand this better, if we look at this, suppose this is a facial recognition model. So if we put in the input, which is obviously the faces, we first layer would just try to identify like a part of an eye, a part of a ear, a part of a mouth, and so on. And the second layer would join those together to form a full eye, a full nose, and so on. And then those will form faces. Another really cool application would be colorizing black and white images. Initially, it used to take a lot of time doing it manually, but now it can be done quickly. So just the basics would be that normally a colored image is stored as an RBG in RBG channel. So each pixel has a red, blue, and green value. But when we do coloring, when we colorize black and white images, we convert that to LAB formats. So L stands for lightness, A for green red, and B for blue yellow. So a black and white image only has L, and we only have to predict the A and B values. So this is basically the L value. So you can see it's the entire black and white image. So again, taking the kid example, as a kid knows that the sky is blue or the sun is yellow, the neural network has to learn the same. So for training it, we use colored images converted to black and white as input. So the predicted output image, then the neural network predicts an output image with A and B values corresponding to each pixel. The error between the prediction and the real image is calculated. And then the network updates its filters, which is basically the weights and all, to reduce the error. And this continues in a loop till we minimize the error. So once we have minimized the error, we can give in any random input image, and it will give a accurate or more like a believable prediction of what the colored image would be. Thank you.
Nice, thank you. That was interesting.
So you are working on DL currently, yeah?
I just started reading about it like a month or two back, but I found it interesting. So yeah.
Nice. Have you written any code? I mean, it's quite interesting when you actually run the models.
Yeah, I do have to try like a proper full project.
Yeah. So there are like some collaboratory notebooks already available. So it's just like plug and play. You don't have to download the code. You just have to like, sort it.
Okay.
Yeah, so you
I will
can
try
have a
that.
look at it.
Yeah.
ऋत्विक का क्या हुआ? I was away from keys कुछ देर.
उसका इलेक्ट्रिसिटी नहीं उसका कोई लाइटनिंग स्ट्राइक हुआ था उसके ट्रांसफार्मर पर.
Oh shit. Oh.
Yes.
ट्रांसफार्मर पे लाइटनिंग स्ट्राइक हुआ.
इलेक्ट्रिकल इंजीनियर हूं मैं, मुझे समझ में नहीं आ रहा क्या व्हाट इज सपोज्ड टू हैपन.
ट्रांसफार्मर पे हुआ ना.
अबे प्रोबेबिलिटी क्या है?
बड़ा लाइटनिंग टॉक कर दिया भाई.
अबे अगर ट्रांसफार्मर हिट किया तो पूरा शहर का उड़ जाएगा ना फिर तो करंट.
अरे ट्रांसफार्मर पे गया है तो ट्रांसफार्मर जहाँ पे डिस्ट्रीब्यूट करता है वहाँ वो चला जाएगा बस.
लोकल ट्रांसफार्मर का
अबे तो मेन ट्रांसफार्मर भी तो होता है ना जो सिटी का कंट्रोल करता है.
ब्रो पास में वो उसी को पता चला ना.
ऑल आई कैन इमेजिन इज कि लाइटनिंग स्ट्राइक और डिस्ट्रॉय हो ट्रांसफार्मर. इलेक्ट्रिकल का फायदा नहीं लग रहा मुझको कि क्या होगा.
लाइटनिंग टॉक.
अरे
लाइटनिंग स्ट्राइक.
सबसे घटिया चीज ये हो सकता है कि उसका मदरबोर्ड फ्राई हो सकता है. और कुछ.
अरे हाँ.
अरे मेरे को वैसे
मेरा हो चुका है एक बार.
लाइटनिंग से मदरबोर्ड कैसे?
यूपीएस नहीं होगा तो फिर वो हो जाएगा.
यूपीएस नहीं, मेरा फ्राई हुआ था. मेरा लैन केबल लगा हुआ था.
ब्रो ही इज बैक. लाइटनिंग आ गया.
Ritwik is back.
Hi Ritwik, are you okay? Is your computer okay? Fry नहीं हुआ कुछ. Hello.
Mic destroyed by lightning.
Lightning
Hello.
disturbed.
Hi, Ritwik.
हाँ like power cut हो गया तो इसलिए.
Oh, okay, okay, cool. No problem.
So like extremely sorry for the interruption. Like it was
भाई
very
ऐसा
awkward.
एब्स्ट्रैक्शन फॉलो कर क्यों कर रहे हो? पावर कट हो गया था.
Don't feel sorry for lightning. It's fine. Sorry.
Thor should feel sorry, not you.
Nice. You can continue from where you stopped. So Anushka actually gave the lightning talk when you were gone.
So actually, I'm not sure where I left off because when I looked at there was this big, like uh, uh, just a second.
You were at the blur sharpen convolution matrix. I think that was very well.
Okay.
I think so.
Yeah, that is the point where you got cut off.
One slide above this. Yes.
Yeah.
This one. I think you
Okay.
done you did this. The next slide, yeah.
Yeah. So I was talking about merging two images together. So basically, what it is that you have suppose you have a group of images, and what we are going to do is we are going to combine all these images into a single image, and on that image we try to capture the difference and similarities between those two images. So that's all. And so as for that, I guess I'm already like you can see I've got two pictures here, this octopus and this Spider-Man. And so what I'm basically doing is I'm accessing all these RGB values and I'm taking the average and I'm setting them to. This is no design at all, no practical application, but like in actual like you know those like dog detection and all these things. Like on the behind the scenes, actually these kind of things are happening. Like number of images are taken together, some functions are applied on the RGB values, and it is trying to pick up on all these features. So this is a simple application, and you can see this kind of effect. And so there are many other ways. Like you can like for the odd number pixel, you can take image from one value and other value and all this. So that is all. So actually, the motivation from all these things come from, and this is basically like once you have access to all these pixels, you can do whatever you like. You can like import a sign function to all these pixels and not practical. So there was this interesting puzzle, this Cicada 3001. So this was a series of puzzle by this guy, this Tiberius Claudius Caesar. So there was actually a Reddit thread, and in that Reddit thread, there was an initial image, and everybody thought that that particular image was like some people were just like making fun of them. But on like when you take the image into a code editor, the bottom of the like the code editor actually doesn't recognize the image, and at the bottom of the image there was a particular link, and that link took the user to another image, and that image has similar kind of hidden information. So all this hidden information ultimately led to this book, this Liber Primer, this name. And you can see there are approximately like 50 pages, and this is the original book, and I think 25 of them have been cracked, and 15 are yet to be cracked, and all this like philosophical writing here, and there's something interesting things like that also, like the primes are sacred, the quotient function is sacred, and all things should be encrypted, and all this information. Like I don't know what is actually so, and this was all the encrypted version, and people have managed to crack it actually, and this has led to this all this information, and like these pages have already been cracked, and there are some other pages like from 0 to 55, I think 56. So like 100 or so pages, like all these pages have not yet been cracked. and it is believed that on tracking all these images, there is a particular page that uses this kind of hashing, and it will lead to, I don't know what is actually this, but so yeah, there are many different puzzles like this on the dark web, and you can like navigate through them, and you can like some of them are like do not have any like make fun of people. Others are little very interesting things. Like there was actually one like a few years back, which led to like two Bitcoin something like as a reward or something. Okay. And the basic of all this like puzzles and like they basically take an image, and in the pixel information they try to hide all this like extended information like about I don't know. So that was actually the motivation behind all this. So that was actually it. Thank you.
Thanks, Ritwik. That was quite interesting. Nice. Also, slide template is also nice.
Thank you.
So that's all for today. Like these are the talks that we had for today.
Yeah, I think all have been covered.
And how many there are for tomorrow?
8, I guess.
Same time?
I mean, I don't think it's well decided yet.
But make sure you send the invites. Like at least tag people who want to attend. Like Himanshu would like to attend. All right. Nice talks, everyone. It was really nice seeing you all explore things, especially those that Google Dorking and all. That was very interesting. By the way, is anybody into Android custom ROMs crashing and all?
Yeah, I used to do that a long time back.
Yep, that was how I started.
Same.
What-
And
Oh,
also how
should
I
I
fried
stop
my first
recording
phone.
before that? Sorry.
Yeah, you can stop recording. Yeah.
Sahil, how do I stop?
I used to do that until the phone its hardware failure came out.
I used to my first custom ROM fried my mother's phone, and I like got scolded so much.
Fortunately, I've never had that experience. I remember there was one time I tried to root my phone, and some some Chinese application got installed permanently. Like it somehow managed to do something about in the internals. Like whenever I used to switch on the phone, some Chinese text used to be displayed for at least 5 to 10 minutes, and after that it will go out. So that was my first experience with rooting, which was a bad experience. But then I got some better phones. I tried rooting, custom OS, and all those stuff. So do you know about Lucky Patcher? Anybody?
Yeah, good old memories when Lucky Patcher used to work.
Lucky Patcher and King Root.
Yes.
Yeah.
Free coins in every game.
Yeah, in-app purchases and all. I still use Lucky Patcher at times. Especially when my father's phone I have to install some application, I first like identify the application. I remove all the ads, and then I install them on the phone because it's much better. Anybody use Greenify?
No.
Greenify is another. It just switch off or force stop all the apps in the background so that it never runs and uses your RAM.
There was also that thing, right, during Lucky Patcher and King Root times, that custom modding thing. I forgot the name of that software.
Magic's Manager.
No, that was before Magis. There was another thing. Like Magis came after that.
Magis is very new, yeah. I'm still using Magis. I still use.
Yeah, same.
Suggesting cyanogen mode.
Oh yeah, the times when Cyanogen mod was still alive.
Yeah, that was the inspiration for that OnePlus ROM, right? Yeah, Oxford.
Yeah.
Yeah, OnePlus ROM is based on that.
And now look at it,
OnePlus.
it's now colorless. Sad. Yeah, I still am into love, modding, like Android custom ROMs and stuff. It's very